Hello folks, for those of you in MAT-113, I'm just moving my pages around, so, geez, even this like wood. Today we're going to be doing section 2.4. Alright, let me look at the calendar here. Okay, today is February 23rd, Tuesday, so we're doing section 2.4. As per the schedule, the calendar. It's good that we're on track here. The packet that I have for you today looks like this. This is part of a diagram. I'm going to project this and then help fill it in. And then there is an actual list of procedures. Basically, this is my sort of rephrasing of the process of constructing a three-set Venn diagram. All right. This information alternatively can be found on the formula page here. This, I decided to save it because I like this diagram. It explains the intricacies of the shorthand mathematic logic symbolic writing. So you see that this is, it's a little fuzzy here, but A intersects B intersects C, right? And then it refers to the specific location in the diagram, right? This biscuit shape here, right, is the intersection of A and B specifically, okay? That I found very useful myself. De Morgan's laws are two laws here, right? This is also swiped from the textbook. And then there are some examples. I'm really only going to use one or two out of these, but I included them just in case you don't see this. So, you know, the solutions are there. You don't have to go fishing for them. All right. And then there's a diagram that that extra question that I threw in. Okay. So I'll definitely go through that. All right. That seems sufficient. Let me put this aside. I have to remind myself to change one thing. I don't know why I did that. I labeled something in my notes here, the wrong section. Slowly slipping into madness, you see. If that hasn't happened already. Yeah, I need to change that. Okay. This is 4. Alright. Alright, I'll mess around with that later. Let's see. Let's get started here. Let me turn on my projector and I'll do as I suggested, which is to have a printout that will fill in. Camera. That isn't too bad actually. Looks like it's okay. Yep, let's do the same thing. Neglect to plug it in. Of course, there's no signal there. There is. Okay. All right. Well, let's see. The first diagram is this one that is labeled Venn 2 and 3 set templates. Now, the last time that we were together, we were talking about Venn diagrams. A diagram being a nice summary of the logical information. And we basically had begun this because we were talking about unions and intersections. So when you have a two-set Venn diagram, very often it is referring to the biscuit that you see here, all right, which would be the intersection. Okay, mind the knocking. It's a renovation next door. This is the subject for today. All right, when you have 3 sets rather than just 2. You keep on knocking, but you can't come in. Alright, so here's what we'll do. Remind you firstly of the labeling of the regions that is done in Roman numerals, of course. Alright, and then extrapolate that on that when we get to this situation, because it's more involved, as you can see. Alright, it is often easier just to refer to the Roman numeral than it is to the symbolic logic of something as an intersection or union or what have you. Especially when you get to that. So remember, this is region 1 for the sake of clarity. Right? This biscuit shape is region 2. That would indeed be the intersection of these two sets. And this is region 3. And if there is nothing else involved here, then the outside of them would be Roman numeral 4. Right? What does that mean? Well, if we were talking about unions, and I'll try to separate myself here. The union of A and B, I'll put this in a different color. The union of A and B would be equal to what things? Hopefully that is visible. It would be equal to the contents of 1 plus the contents of 2 plus the contents of 3. All right. If we were talking about the intersection of A and B, then it would just be the contents of 2. All right. And if we were talking about neither, then that would be region 4. Okay. I think I may have to shut my bathroom door here just to keep the light out. Alright, that's not so bad. Alright. Hopefully that is visible enough. Now, when you get to the 3-set situation, we would continue naturally with the labeling of Roman numerals, but there'll be more of them, as you can see. All right. This is still 1, but it's shrunken, as you can see, because it has another overlap with the 3rd set. All right. Just this sort of almost Star Trek-esque symbol in here. That's 2. All right. And this is 3. And then this other little sort of curved triangular shape. It's not quite a Roy-Lowe triangle, that's what the center is, but it's something that's truncated. There's nothing that comes to mind. It's like Star Trek, 4 is now this space, because the dead center is 5, and 5 is actually going to be very important when you're trying to fill this out for an actual example. All right. And this is 6. All right. Remember, when you're writing things in Roman numerals, you subtract by putting the smaller thing on the left side, and you add when you put the smaller quantity on the right side. All right, so this is 6, and this sort of moon shape in here, this is like Lucky Charms, right? This is 7. All right, and then the very outside, that includes none of these 3. This is 8, right? Now it is possible to have some more Roman numerals, but you would need more circles involved here, and I don't think you're inclined to see that. All right, so that is that. Now, as to I'm giving you maybe too much information, but you could see, as I mentioned on this sheet, right? And that's why it's still useful. What the particular shaded regions would equate to in terms of the symbolic logic here. So, like, even in the case of a 3 overlapping circle, a 3-set Venn diagram, this sort of biscuit shape that is in here is still the intersection of A and B, but it is comprised of two regions rather than what normally is the case, one region, just two. Okay? And the very dead center of this is the intersection of A and B and also C. Right? It's just those things that they have in common. Right? I must have been out of my mind when I wrote some of this stuff. I keep catching mistakes in my notes here. Let's see. Right. As I mentioned, 5 is going to be very important, right? When you have a specific example, I'm going to walk you through it a little bit, that you have to fill in the actual diagram with the parts that they give you, you always start with 5, all right, the dead center, right? And officially, 5 is what would be the intersection of A and B and then also C. It is the overlap of all three. Okay. The union, if you're curious, would be what? The union of A and B and C would be the sum of virtually all of these things up to 7. Right? So it would be 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7. Right? And not 8 because 8 is beyond them. Okay. All right. This is a fun sort of fact. This sort of shape that you see in here now, it looks sort of like kind of a little shield, if you will. I'm going to just trace this in black here to emphasize it. All right. That has a name, believe it or not. This is a Royleau, R-E-U. L-E-A-U-X. It's French, right? Royleau triangle. And I believe that is the correct pronunciation. I took Latin when I was in college. I did not speak French, so forgive me if I've mispronounced it. Anyhow, I always liked that shape myself. This is something that appears in architecture a lot of times, in old sort of cathedral windows and things. The inside of the rotary engine is also a three-dimensional Royleau triangle, really. That's the part that is used in place of a piston. All right, now let me switch slides here, and we'll discuss actual procedures. This is, if you're looking to print it, it is, I think I labeled it how so here. Venn diagram 3-set how-to. There's a lot of the same diagram or derivatives of the same diagram. Let me erase this because it's too much clutter. There we go. Continue. The green is being stubborn today. Problematic markers. Okay. I'll take this. All right. If you had to fill in a 3-set Venn diagram, this is the order of operations. As I mentioned, right? You want to start with the dead center. You notice I didn't put two I's, 3 I's, IV, V, and VI, and VII, because that's something that You can always have a reference, of course, that you want to memorize that is the arrangement, right? Left to right, 1, 2, 3, 4, 5, 6, 7, right? Because in an actual example, you'll see in a moment, you're going to be filling in those regions with whatever the elements are from the sets, okay? So you start with V, meaning you're starting with the Roy-Lowe triangle, the dead center here, right? And what is it? It is the stuff that is in common to all three sets, right? Then you do 2, which is the part of A that is exclusively, well, rather here. This is just adjacent to it, right? The stuff that is common to A and B only, right? That is excluding C, essentially. Then you do 4, right? Which is the stuff that is common to A and C only, right? Then you do 6. So essentially, you start out with the center of the flower here, right? And then you do this petal, right? And then this petal, and then this petal, right? Looks like Celtic knots now, right? And then you do the sort of tried and true things that are A here and things that are B here, exclusively at each of those. And then you do the stuff that is C, which is labeled 7. Okay? Anything that does not get put into the diagram gets put into region 8. Okay? So, let's do an example together to illustrate this. And for that sake, all right, I'm going to steal the one example that I'd like from this packet, which is example 1. Okay? Now here is how you would see it. All right? Construct a Venn diagram illustrating the following. And then it tells you that this is the universal set, meaning everything, all the contents in the box. This is set A, B, and C respectively. All right? And we're just going to basically put these in the appropriate places. Even if you weren't given any other information, nothing about the solution here, you could infer, right, how the diagram would look. Right? Now, it's going to be a little bit tricky because I need to sort of like have the information listed. So what I think I'm going to do is I'm going to physically write some of this information that is here. All right, maybe rephrase it. And then have a blank adjacent to it. Right. So humor me for a moment while I finagle that.
0, 8, 3. So that's the route. Yes, sir, you got it. So just provide that to your employer online, and then direct deposit should be able to come through. No problem. Was there anything else I could help for you? Okay, Jason. And that's it. I hope you have a great day and stay safe, okay? You're welcome.
Bear with me, I'm sorry. I really just need this much information. And just to have the procedures handy, what I'll do is I'll keep this on top here. That should work. All right. Now, if you look at the contents here, all right, of the universal set, you have numbers 1, 2, 3, all the way through 14. All right, and then naturally, when you have subsets A, B, and C, there's less contents, but some of them are going to be the same. All right. We are going to start here, taking the advice of starting with 5 here, which is in Comic Sans, so it doesn't have its top and its bottom here. All right. We have to pay attention to these three immediately, right? And look for, I'm going to just circle the things that we arrive at as being in common to all three at the same time, right? So if you look at the, this is tedious, right? But if you look at the number 1 here, all right, is 1 in all three sets? It isn't, right? So you see 1 in A and C, but not in B. So we can't put it in the center, all right? And then we're going to look at the number 2. Does the number 2, is it included in all three sets? No, it is exclusively in B. Then the number 3, same issue. It's just in C. 4 is just in B. But when you finally get to the number 5, you see that the number 5, all right, is in all three sets. So 5 would indeed be in the center. All right. Now we'll run the gamut here, check the other things. 6 does not appear in any of these, right? 7, or does 7, right? But the number 8 shows up next, in 2, right, only. And then the number 9, right? Number 9 is actually in all three sets. We're going to put 5 and 9 in the dead center. It's a sloppy looking 5, so 5, 9. So 5, 9, 59. Okay. And that should be in the center. I'm sorry, my marker is a little bit fat here. Alright, there we go. That'll have to do. Check the rest of them. Alright. 10 is only in 2. 11 is only in one of them. 12 is only in one of them, and 13 is only in one of them, and then 14 doesn't show up at all. So, what is just in V? 5 and 9. Okay. Continuing, all right. Now we're going to do region 2, which is just above. All right, that would be things that are just in A and in B. All right, and get a little messy, so I'm going to erase a little bit as I go along. This is the one benefit of having a whiteboard. All right, if we're concerned with this Star Trek sort of pedal here, just above the 5 and the 9, region 2. All right. Then our focus would be limited to just these two, all right? Let's look for things, again, that occur in both of them, all right? Does 1 occur in both of them? It doesn't. Does 2 occur in both of them? It also doesn't, all right? There's a glare. Jeez, that is the slimmest little... There we go, that'll have to do. Okay, 3 doesn't show up at all. 4 is not in both of them. 5 is already accounted for. 6 is not in either of them. 7 is not in either of them. 8 is only in A. 9 is already accounted for, right? But finally we get to something that works. 10 is in both of them. So we're going to put a 10 in here. Alright, 11 is in neither, 12 is in 1, 13 is in 1. Okay, now we will do region 4. Region 4 is a little less familiar, right? But it is this pedal that is down here. Alright, so once again, our focus is going to have to shift. Alright, now if we're concerned with this petal here, alright, then we need to pay attention to what is in A and what is in C. All right? We're going to ignore B for the moment, so I'm just going to scribble in between it. And we'll look for things that are the same. All right? 1s occur in both of these. All right? And it's not showing up anywhere else, so there's a 1 in here. 3 is just 2. I have to go through them logically. 2 is not included. 3 is just in C. 4 is not included. 5 is in common, but it's already accounted for. 6 is in neither. 7 is in neither. 8 is in both of these. All right? And that's not anywhere else, so we're going to include an 8 as well. Okay. Sorry. Wrong place. I'm not taking my own advice here. It's more an 8. In the biscuit that's down here. Sorry. Alright. Ding dong. Okay. check the rest. 9 is already accounted for. 10 is just in 1, 11 is just in 1, 12 is just in 1, and then you run out of numbers. Okay. So, moving on. The next one is region 6, all right, which is this particular petal here. And don't do what I just did, which is start filling in this. Region 4 was this biscuit. All right. B and C means that our focus is now just these two. Right. So, running out of distinct colors, I'm going to try this green reluctantly. 1 does not show up in both. 2 does not show up in both. 3 does not show up in both, nor does 4. 5 is already again accounted for. Alright, 6 is in neither, 7 is in neither, 8 is just in C. 9 is already accounted for. 10 is in A, pardon me, 10 is in B only. 11 is in C only, 12 isn't included. 13 is just in B, and 14 is not included at all. So this one ends up being just blank, right? There's nothing in there that is in common. So that's done. Okay. All right. Next one, now finally we're going to go to A, right? So we use red. Things that are only in A, right? Well, we know that we can't use 10. Strategy is going to change a little bit. I'm going to cancel out stuff. Because 10 is not exclusively in A. We can't use 5 is the same reason. It's part of something else as well. Nor 9, right? Nor 1, nor 8. The only thing that would be left over that is truly A is 12. And therefore we're going to put a 12 in here. Okay? Now we're going to do region 3, which would be just this sort of moon shape again. In here, Lucky Charms. That is just B. Alright, so we'll again change the strategy just a little bit. I'm going to cross out some stuff now. Alright. In B, alright. B, right off the bat, right, we have this number 2 here, alright. 2, you know what, let me start with crossing out first, and we'll just get back to that. What is B, what are the elements of B that show up someplace else? 5 and 9 we already knew immediately. 10 is part of A, alright? And as far as B is concerned, that's pretty much it. So what is left over from B? Alright, 2, 4, and apparently 13. So you could just slip 2, 4, and 13 in here. Okay, now things that are just C only. So I'm going to try green again. I cross out the stuff that is included elsewhere. Alright, again 5 and 9 go away immediately because they were in the center. Alright, 1 and 8 in the case of A and C. And that leaves you with just 3 and 11. Right. So you have a 3 in here and you have an 11. Okay. Now the last thing, and this is kind of satisfying I think, when you're considering the leftovers, for lack of a more eloquent expression, from the universal set, they would have to go in sort of this outside hole, donut shape if you will. And when you're doing that, right, again, your focus is now on the universal set. And we're going to cross out these elements that show up somewhere already, right? So, is 1 already accounted for somewhere? Can I go to sleep with me now? Yes, so I'm going to cross out 1 is already used. It's not 18, it's 1. All right, 2 is already used. All right, 3 is already used. All right, 4 is already used, 5 certainly. 6 is not. Alright, so I'm going to circle that. 6 would end up having to be here. Alright, same thing with 7. 7 is not included, so just put 7 somewhere on the outside. Alright, 8 is included already elsewhere. 9 certainly from the very beginning. 10, alright, 11, 12, and 13. Alright, that means that there's only one other thing, 14, that has to be written someplace else. Alright, so that's pretty much the way the diagram would look. Right? What eventually will happen is that you'll draw the diagram, and then they'll ask you a slew of questions about, well, what are the rasta? What are the specific elements, the contents of these interrelationships? Okay. So if they do, I mean, here's the ones that are really the most interesting right off the bat. I'll move this. Let's put that aside for a moment. The intersection of A, B, and C, which again is the Roy-Lowe triangle in the center, is the rasta 5 and 9, right, and nothing else, right? If they asked you for the intersection of A and B, rather than the intersection of A, B, and also C, maybe I'll put this in a different color just for the sake of distinction here. Just beware, all right? The intersection is not just the thing that are A and B exclusively, which would be 10, but the intersection of A and B is still this biscuit shape, right? All right, so I mean, in theory, that would be 5, 9, and 10. Okay, now it can get a little cumbersome, which is why, again, I threw in this diagram swiped from the textbook. All right. So take a look here. All right, notice the shaded region. All right, and this is a 3-set diagram, right? The intersection of A and B. All right. We would like it to be, you know, just region 2, but region 2 has been sharing the same real estate as, you know, region 5. All right. So the intersection of A and B is in fact still the same biscuit shape, right? Right, which would mean that it is 10, 5, and 9, right? Because that's region 2 and this is region 5. It's a little bit tricky to get used to, right? All right, so use this reference, right, when you're going through your work. All right. Now let's talk about De Morgan's laws. I'm going to change this slide here. All right, I got rid of that. Sorry. Okay. Here's your copy of what the schematics is I was telling you. All right, and notice again. Notice again that this nicely summarizes all possible combinations here. Region 2 and 5 is the intersection of A and B in the case of a 3-set Venn diagram. All right. Now here's De Morgan's laws.
their
Right.
account
Yeah.
is up to date, and they're sending out checks that don't have sufficient money, they're gonna get in big trouble.
All right. Now, De Morgan's laws are basically these two. Notice that there's the apostrophe, tick mark, prime mark, whatever you want to call it, included in this. If you were going to read this out loud, it would be the complement of the intersection of A and B. So, for one, let me just verbalize it because I hope that helps. All right. The complement
You might have not had it available at the time.
of
So Phil knows it was back.
the intersection of A and B, right, is just basically that much verbalized, right? What does the complement actually mean? Remember, the complement is everything that is not, right? So what you would have to do is first find the intersection of A and B, and then look specifically for things that are not that, right? It's maybe a little kooky, right? The benefit of being at least aware of De Morgan's laws is this, that if you find that sort of approach to the question confusing, right, what you can use instead that is equivalent is just the complement of A, just the complement of B as a union instead. If you can figure out what the complement of A is, the things that are not A, and then the things that are not B, and then unite them, right? Because it would be all from both, all right? You will get the same answer, right, essentially. Because I'm short on space, let me erase this now. When you're looking at 2 here, all right, 2 is, again, notice the apostrophe, the complement
I'm sorry, it sounds so back and forth. Even, I said, yeah.
of the union A, B,
Yeah, because absolutely, because I'll go through
All right.
it. You had a
And again, what does that mean? It means everything not
account history quickly just to show you, but, or explain rather.
that condition, all right? Complements are looking for not, all right? So you would figure out what is the union of A, B, right? And then figure out everything that is not that, right? And if that is confusing, which is understandable, all right, the alternative approach to it is that you could figure out things that are not A, the complement of A, and figure out things that are not B, the complement of B, and then figure out their intersection in this case. So it's one of those situations. The De Morgan's laws exist for the practical reason, at least. All right, so that you have an alternative pathway to the same question, the same solution. Okay. The complement of the union. All right. The complement of the union is the intersection of the complement of A and the complement of B. Okay. All right, let's do an example to illustrate this type of question. And this is, I don't remember if I took this in the book or not. I gotta buff this out, humor me. Okay. I'm wondering, did I steal this from the book or did I steal this from someplace else? No, I think this is from a different textbook. So, let me write what I'm going to show you now. Okay. And I'll pull back the curtain and turn off the projector. Yay, sunlight. Okay, now hopefully this is sufficient enough light. write it here. It's not going to take too long. All right. This is an example for De Morgan's laws. I like to rephrase these, so I'm going to be writing it in a concise way. Just to set a good example, when you do a problem that you identify as requiring De Morgan's laws, do not be afraid to rephrase it in a way that is more concise, as long as it is accurate. All right? If this is the universal set, and maybe I'll just give it a little bit of flair to make it not look like a union or intersection symbol. So letters A through H. So A, B, C, D, E, F, G, H. All right. And, all right, the set A is some of those things. It's a subset. So A, C, E, and G specifically. And this writes so nicely all of a sudden. Set B is again a subset, so it's some of those things. B, C, D, and E. All right. That is fine. The union, the complement of the union, A, B. I'm just hesitating because I'm wondering if I wrote the wrong symbol before. I don't think I did, but if I have to, I'll check it when I'm editing. All right. Let's see. Okay, so this is the objective, what you see in blue here. All right. A intersection B. Sorry if that's not the best. This, I swear, is the union symbol, not the universal set symbol. A union B, and we're looking for the complement. All right. De Morgan's laws, all right, tell us that as an option, if we want, all right, we can identify firstly the complement of A independently of anything else, all right? And then the complement of B, all right, and then as an afterthought, find their intersection. So I'll put this just to make it a little bit more distinct. Okay, so basically, when you're given a problem like this, try to figure this out first, right? Try to figure this out second, and then figure out their intersection third, okay? In terms of a procedure. All right. The complement of the union of A and B would be the same as the intersection of the complement of A and complement of B. So figure out this, and then try to figure out where they overlap. All right, remember, intersections are overlap. All right, it can get a little messy, all right, especially if you're short on space. All right. I'm going to be a little bit short on space myself, so let me erase a little bit above here without doing too much damage. Sometimes the better the marker writes, the more sticky it is. Okay. Okay. I'm going to need to borrow basically the information in here 2 times. Okay? And if it makes sense, duplicate the information in 2 places. Alright? So, again, humor me because I'm very short on space, so I'm going to have to write this in 2 different places. Okay. If this is U, I'm just writing a little bit tinier. A, B, C, D, E, F, G, H. All right. And we're just focusing on A for a moment. And A is this information, A, C, E, and G specifically. What is a complement? I'm going to duplicate the information looking for B prime over here. Right? If U is again A, B, C, D, E, F, G, H. And in this instance, B is equal to B, C, D, E. We're going to look for B prime. Alright, now that I've duplicated it in 2 places, what I'm going to do is I'm going to erase this so that I have the free space to work. Okay, let me just make sure that I duplicated it correctly. Let's see. C, E, G, okay, B, C, D, E, good. Right, I need to erase this now. To answer the question of what is this going to be, the roster of A prime, and then later the roster of B prime. Right. Let's cross out things that occur in both A and U. Cross out matches here and here, alright? Because we're looking for things that are ultimately not A, alright? A is part of U. So I'm going to cross out these 2.
Okay, so there is already a username set up.
Alright, B does not show up here, alright? C is a match, so I'm going to cross that out. D doesn't show up here. E is a match, so we cross that out. F doesn't show up here, but G is a match. Okay. Now, circle the leftovers.
Okay. Yeah. In this case, it is. I'm not sure.
Sorry for that rocking. That's my T-square. Okay. Circle the matches that are leftovers. All right. Cross out the matches in between. Circle the leftovers in U. Right, so B would be left over, right? D would be left over, F would be left over, and H would be left over. Right. So we're going to save B, D, F, H to work with when we get to the intersection eventually. Now we're going to do almost the same thing with the B set. Okay.
Just have the computer repeat it to you a couple of times and maybe type it out.
So same process. We're going to cross out the matches here and here.
Okay.
All right.
So I'm gonna send.
B is a match, goes away. C is a match. D is a match.
If you could either.
And E is a match.
Or you could end the call, it's up to you.
And then we're going to circle what is left over. In U. Right. A is left over. F is left over. G is left over. And H is left over. I really should be putting commas here. A lot of times I don't do that because of the, really just because of the chisel tip of my marker is a bit too prominent for its own good. So it might make things look like an element that isn't just a separator here. Okay. So now if we're looking for the intersection, the intersection is going to be, right, those things that just overlap.
I'm sorry.
If we take this information
Mail is telling you to press what?
to answer this question, what is the intersection? That's a dud.
It's not saying anything else.
Of not A and not B. Then we need to look at this particular list and this particular list, right? And what we would do naturally is
I'm gonna send that call and then we'll
circle what matches in this case.
take care of from here. And if not, you can call me back. Alright, I just don't wanna mess you up.
Right.
That's all. So
What do these two things have in common? They don't have B in common. They don't have D in common. But as you can see, they have F in common. So the roster of this would be F, and then they also do not have G in common, but they do have H in common.
you're not gonna receive a late notice until 10
H.
days from now. You're probably only 5
So,
days late.
the union
You have
of A or B,
um,
the complement of the union A, B,
so
could be figured out by finding the complement that is not A, the complement that is not B, and then their intersection, right? And this is ultimately what you're left with, F, H. Okay. Okay? Sometimes it's easier to look at things one way versus another. Okay. All right, one more of these and then I'll stop. If you're following along with me, all right, I made this example, all right, so we'll figure out the roster of this situation, all right, which is a little peculiar, using this diagram. And to that end, let me turn the projector back on and adjust the lighting. So tenacious. That would be my older sister, who I never got to take to the optometrist yesterday, so give me one moment. Okay. Yep. We'll Okay. Let me switch the slide here. And look at this blank here. Okay. Oh boy. This one, sorry. Alright, I'm going to sort of move this over a bit and create a nice white surface for myself. So give me one moment. And my PowerPoint does the dance here. Yippee-yahoo-y, okay.
It's the same account and routing number. The only difference is the card number.
Yeah,
So
right,
card
we'll
numbers
do.
don't really matter.
Okay. Oh, you know what? I'm torturing myself needlessly. My bootleg paint is better sometimes. Yeah. Yes, that is better. Okay.
Is it possible?
All right.
They already issued the refund?
So I just need this diagram and I need the instruction. I don't want to shrink it too much here. Okay. All right. As long as that is visible, this is sufficient to work. All right. I think you can see that. Looks like it's all right. I wish my light was not leaking in somewhere today. All right. All these technical difficulties. That was weird. All right. Focus. All right. Let's start by deciphering what this actually says. Let's write this at least in English. All right. That's just because that is all that I know, and I should know other things, but for the purposes of instruction, humanly, we'll write this in English. Okay. This is asking, right? Right.
I'm trying to look up Darius.
In English, at least. Right. The intersection of C
You're a member number.
and
I'm trying to look up you in my system.
the union of AB.
Okay, there you are, Darian. Could you just quickly verify the date of birth?
I should use the word or.
Okay, thank you. What kind of accounts do you have?
Okay, remember and is the word you want to reserve for intersections. I know it's very difficult, especially English gets you in trouble, right? But and is for intersections, or is for unions. Okay. When somebody uses those words interchangeably, erroneously, forgive them, of course, because you know what they mean. Right? It's sort of like when a little kid goes up to you and says, "I ain't done nothing," right? You know that they're not really trying to admit any guilt, even if technically they are. I ain't done nothing, Grandma. You know. I said that to my grandmother many years ago, playing with matches. You know, I ain't done nothing, Grandma. And technically, I had done something because ain't is negative, right? And nothing is negative. Anyhow, the intersection of C and the union A or B, the union of A or B, right? Now, as a procedure, what we should probably do is stick with the foundational logic that we've always had, right, which is follow the order of operations. Right? What would your instincts tell you at this point in your math life? All right, and don't laugh at that. All right, you're probably like, why would I laugh at it? It's just a stupid joke to begin with. Your math life is the best life, right? So anyhow, what would your instinct tell you you should focus on? All right, when you see, you know, some abbreviations from order of operations is what I'm getting at. The parentheses, right, is what I mean. Right? If you see something in parentheses, even if it, you know, we read left to right, of course, but even if it is secondary in the scribble, okay, our focus really should be here first, okay? So what we're going to calculate is what is the union of A and B first, all right? And then, as an afterthought, we will consider the actual intersection. It's counterintuitive, right? Because you see C show up in the front, all right? There's another instance of English getting you in trouble. See the letter and C is look, all right? Ambiguity. Anyhow, there's different contexts. So we're going to basically figure out what A union B is, all right? And then we will conclude what the intersection is with C. That is essentially following the order of operations. The parentheses is meant to draw your attention. Okay? So let me erase this because I need the space. Okay? Now, I wonder if I open the curtain if it would be easy to see now. I don't want to make more trouble, but let's see. Is that now? It's kind of killing it. All right, leave it alone. All right, so let's establish again this, right? Where would be the union? You could scribble on the diagram. What would be the union under ordinary circumstances of A and B? A or B, I should technically say. All right? It would be everything in this particular shaded region. So, and this is again, the advantage to having a whiteboard is that at least you can draw on top of something and then erase it without really doing too much damage. All right, so the Scotch plaid that I have drawn here, all right, those are the elements that are the union, all right? So let's list them, all right? And we'll try to put them in numerical order. I mean, it doesn't really have to be, but it would help, all right? So as a roster, A union B would be equal to this, all right? It is apparently 1. Let's see if there's a 2. There isn't. Next thing is 3, all right? And I'm not going to use commas just for the time being. 4, all right? And then 5 is outside of that region. 6 is outside the region. 7, all right? And then 8, all right? And then 9. All right, let's see if 11 shows up here. No, it's outside. And then 12. No, 10, sorry. 10, 12. And then 13. And then 14, it looks like. Sorry if that's a little dark there. Okay. Alright, is that everything that is in the Scotch plaid region here? Looks like it is. Alright, 1, 3, 4, 7, 8, 9, 10, 12, 13, 14. I believe that is correct. Okay, good. Alright, now, as the next thought here, and I'm going to take advantage of the fact that I have a projected image that I can erase. I'm going to erase my plaid here and zero in on things that are C, all right? If I'm talking about C in general, I'm going to scribble on that portion of the drawing that is just C. So I'll take the green marker because that seems logical, and I'm going to shade this region to sort of draw my own focus here. All right. Here's my ugly candy stripe, which I'm going to make plaid. Almost in time for St. Patty's Day, right? Looks nicer as a plaid, I think, quite frankly. All right. C, I'm going to just write underneath this. This is becoming a dud. So let me just get rid of that one and try a different one. That's better. Is that visible on camera? It looks like it's okay. All right, let's consider the roster that is C in this case, all right? Just the things that are within the region that is scribbled upon in green here. All right, if it makes it a little bit more prominent, I'll do this. All right, now, again, it doesn't have to be in numerical order, but it's organized, right? So we're gonna start with 4, it looks like. 4, all right, then 5, all right, then looks like 9 is the next one, 9, yeah. And let's see, 10 and 13 looks like, 10 and 13, all right, now if the original question is we're looking for the intersection of these two groupings, right? We have everything that we need to make that determination right now, right? The intersection, just remember, convince yourself, it's the overlap, right? Things that match. So I purposely wrote this stacked because I think it's a little bit easier to see what is the same and what isn't, all right? Immediately, they have a 4 in common, all right? They do not have a 1, a 2, a 3, nor a 5, a 6, a 7, an 8. Yeah, come on. But they next have a 9 in common, right? And apparently they have a 10 in common, all right? And a 13 in common. All right. So to answer the question, what would be the roster of this whole kit and caboodle? It would be just the overlap. All right, what are the things in common? It would be 4, 9, 10, and 13. 4, 9, 10, and 13. Okay, I think that's it. All right. Do not feel bad if while you're doing this, you stumble quite a bit. As you can see, I'm probably a little sketchy myself. All right, you have to second guess yourself because you're translating something from whatever your native language is, right, into something that is the universal math symbols. And the universal math symbols, although they should be, universal in the classic sense, right, they're more alien to humans, right? So there's a little bit of a delay, like if you've ever, you try to download something and there's some buffering, don't feel bad if your brain starts buffering and you're going, wait a minute, am I sure? We're all buffering. Let me turn this off. Okay, that's it. That's really the extent to what you would be responsible for in my lab. As a matter of fact, I believe I stole one of these from my lab. Right. And I'll drop it. Okay. So for homework, naturally, right, if you keep in pace, right, do section 2-4. Right, in my lab, and then everything is fair and square. Okay? All right. Thank you guys. I'll see you again on Wednesday. Be careful out there.